Hi guys, welcome to our channel, Automate Friendly. This video series will take you through implementing an Agile solution in controls software development, in which several developers working on a software project can carry out an automated build and test, and then get the test results immediately, with the goal of improving software quality. So, I will be showing you how to set up the process in this video series. In the next 2 minutes, let me quickly discuss what this continuous integration process entails, and then we proceed to show how to set it up in TI Portal. So, how would the process work? Here is a closer look at the CI workflow in this page. Here we see a diagrammatic representation of the CI process. Basically, you would have a number of programmers working on a project in TIA Portal, and then you would have a source or version control system where the project is stored and all the developers can access the project in their various engineering workstations. Here we'll be making use of the TIA Portal multi-user project server as the version system, or also referred to as the source control. So when there's a new revision of the project in the version control system, a test will automatically be done. Basically, if you are new to continuous integration, as we proceed in this video series, I will explain in details how it works to you and how to set it up. We will be using the Siemens provided tools in TIA Portal. First, we'll be using Jenkins as the orchestrating software for continuous integration. And then in a separate video, we will use GitHub as the continuous integration orchestrating software. In this video series, we will start by walking through how to set up this CI process on TIA Portal v17, and then in another video part, we show how to set it up on TIA v19 using the new features the v19 has. Link to the video can be found in description below. In this video part, we will start by showing how to set up Jenkins, and then we will show how to set up the multi-user server, which is the version control system, and then we will show how to integrate and configure the Siemens tools for the continuous integration process. And finally, in this video, we will run the automated unit testing using Jenkins on TI Portal v17. In another video part, we will show the new features in TIA v19 and how to run an automated test on a safety integrated project. At the end of these tutorial sections, you will be able to set up your TIA Portal project for an Agile development process. Don't forget to click on the subscribe button, like or share, as you may have found any of our videos helpful. And if you would like us to set up this CI process workflow in your control system, do kindly reach out to us via the email address in the description. I will show a quick demo of what will be achieved at the end of this continuous integration setup, as described in the workflow. Here is TA Portal opened. You would have a number of engineers working on a project in TA Portal, and right now I am connected to the project multi-user server indicated by the green icon. The multi-user server, which is the source or version control system, where the project is stored and all the developers can access the project in their various engineering workstations. In the multi-user project server administration window is the project named Jenkins_CI, and in the history window of this project, we have the revisions of the project, indicating new changes made by any developer connected to this project. Back to TIA Portal, I have a simple FB that adds 2 values and gives the output. I also have TestSuite installed where I would write my test cases. Here in the project tree, you find the TestSuite tool, and I have my test cases written here in TestSuite. Basically, the test cases contain statements that checks if certain functionalities in the software holds or not. We will look at how to set it up later in the video. So whenever I make changes to the project here and click on this icon to check in to the source control where all the engineers are connected, I get a new revision. I have Jenkins, which is the CI server, which knows there is a new revision with the aid of a listen console script. This new detection will get TIA Portal in a remote computer to open the project and carry out the testing of the project. Here, I have the listen console script checking for a new revision. Here is Jenkins automating the test process. And at the end of the automated test execution, the test result will be stored as an XML file and can be sent to you via email. In this video, we will walk through the continuous integration setup step by step. I will carry out this setup on a single computer, so all the applications will be on one computer, that is Jenkins, the source control server, will all be on a single computer, and the applications will interact as described in the diagram. Following the workflow diagram, first you definitely need the TAA portal installed in your engineering desktop as a programmer. What else would we need? We need TAA TestSuite Advanced installed. This helps you to write the test cases that helps test your program functionality, and when TestSuite is installed, you get the TestSuite plugin in your TIA portal environment. We also need the project server or version control system where the project can be version controlled and every programmer can work on the same project. And we also need Jenkins installed in the continuous integration server, which orchestrates the testing and publishing the results. In addition, we need certain setup files, which are provided by Siemens here in this page. Link can be found in the description below. These setup files are needed for the connection between these different systems. That is, the setup files help connect Jenkins and the version control server. These files can be downloaded in this page to carry out this setup, and I will be referring to these documents while carrying out the setup. Here I have downloaded the files. Now, we will start by setting up the Jenkins, which is the continuous integration server that automates the workflow. Then we proceed to set up the version control server. When we are done setting up the version control server, we will proceed to set up the automation desktop to connect to the project server, to Jenkins, and to ensure this desktop receives the call from Jenkins to run the test cases. I will also show some errors that may be encountered while setting this up and how they can be resolved. All this will get clearer as we proceed.
Okay, I will now take over from here. We start by setting up Jenkins, which is the continuous integration server. Mind you, if you are doing the continuous integration in your organization, it's likely you have a managed Jenkins server in your organization. You may need to contact your IT department to help with the Jenkins configuration that we will show as we set up Jenkins in this video. So assuming we do not have a managed Jenkins server and we need to install Jenkins on a computer, we will take the following steps to get it configured. I will open the Jenkins setup documentation. To set up Jenkins, first, we need to install Java SDK. You can find the link to download Java and also the link to download Jenkins in the description below. I'm going to open my browser and go to adoptium.net to download Java. Or I can just search for download Java and download the JDK 17-21, which is compatible with Jenkins. We select Marketplace and download the latest from Microsoft. If adoptium.net doesn't work, you can check with Oracle. Here in Oracle, I select the version 21, which is compatible with the Jenkins application, and then I select the Windows tab and proceed to download the MSI file. Now I'm going to go to download the Jenkins application. Here I type in Jenkins download in Google, which takes me to jenkins.io. I will stick with the LTS for Windows version. Now I will proceed to install the Java SDK. And here at the custom setup, I will need to set the Java home variable to be installed on local drive. Now that Java is installed, I will access the Edit System Environment Settings, click on Environment Variables, and here at the system variables, I will edit Java_home variable by removing the trailing slash at the end. Having done that, I will open the path options. Here, I will replace the file path to this string parameter Java_home. Now, we can verify this on command prompt by typing java/version, and we can see the Java version installed. Also, we can see the installed Java path by typing in echo java_home. Now that we have Java SDK set up, we can proceed to install Jenkins. Do kindly like and subscribe to get latest updates like this from our channel. To install Jenkins, we need a user account with secured credentials. This account I am logged in with is not secured, so this means I will need to add a password to this user. Having done so, let's proceed to install Jenkins. Here, I will add the user account and click on Test Credential. It gives a warning, which means we need to add the user account to the logon service. This can be done by adding the user account to the service group policies. To do this, we open Local Security Policy, click Local Policies in the File pane, open User Right Assignment, and check for Log On as a Service, then click on Add User or Group. In this field, I will be adding the user account which I have here. I will test the credentials again, and now it's checked successfully. Here we define the port to be used for the Jenkins service, which is port 8080. Here is where we need to define the Java file installed. Note that Jenkins supports Java JDK 17 to 21. For example, here in this computer I had downloaded JDK 24, and this is the result I get. You can't proceed with the installation. But with version 21, which I have now selected, Jenkins can be installed. As we proceed, we need to disable Start Service because we need to make some changes in the Jenkins XML file, after which we can start the Jenkins service. Now the installation is complete. We can now edit the Jenkins XML file by assigning more memory, as this is recommended in the Jenkins setup documentation. Here's the XML file, which can be found in the Program Files Jenkins folder of the C drive, and I will proceed to modify the memory as recommended. Do kindly like and subscribe to get latest updates like this from our channel. Now we open Services and start Jenkins. Here we see that the Jenkins service is running. Now we can proceed to open the browser to access Jenkins. We will be accessing the application via localhost 8080. We can get the password to unlock Jenkins from the file path provided here. Here I have the password. Click Continue, and we can select Install Suggested Plugins. When the plugins are installed, you would proceed to create an admin user to log in into this Jenkins application. We proceed by clicking on Save and Finish. Here we have the Jenkins environment. If you log in into Jenkins for the first time, you should have something like this. As we continue the setup, you would understand the Jenkins interface. Following the documentation, we proceed by creating an API token for this user. This section in the Jenkins documentation shows us how. The generated token will serve as a credential to enable the automation desktop system to connect to this Jenkins server securely, as we will see in the later part of this tutorial. Back to this diagram. Here's the automation desktop. This computer will be able to connect to Jenkins via a configuration file, which uses the token. This automation desktop helps to check if there are new revisions in the version control system, which we will set up soon, and then this automation desktop will launch a Jenkins job to do an automated test. To create a token, I will click on the user profile. Here, this will direct me to this page, and I will click on Configure. Next, I will click on Add Token and Generate. Make sure to save the token somewhere, else it would not appear again. Having generated a token, we need to create a Jenkins node. This node represents the remote automation desktop being connected to Jenkins. Basically, Jenkins can tell this automation desktop what to do because it has a connection via this node that we will create. Here is the section that explains the node configuration. Now I will head back to the dashboard and select Manage Jenkins. First, In the security options, I will define a fixed port for inbound connection to the agent. As defined in the document, we assign the value of 5000 in the field. To create a node, I will select Node Options and click on Add New Node. I will assign the node name and select Create. Here I will define additional parameters. In the documentation here, we see the parameters to be filled into the fields to create the node. Here I provide a short description, and here I fill in the Jenkins root directory that we are to create in the remote automation desktop. You would see in the coming steps that we will create a folder called Jenkins in the root directory. The labels represents an identifier for this node, and I call it Jenkins_CI. The settings carried here are gotten from the documentation. I will just continue as provided in the document and click Save. Here, we have the Jenkins node created. Now we need to create this folder path in the automation desktop. In this folder path, Jenkins stores its data, and also log files that are generated in Jenkins will be stored here. Here is assumed to be the remote automation desktop, which is to connect to Jenkins. So I will be creating the folders in the C drive. Should you want to integrate the CI process in your process workflow, do kindly reach out to me via the email address in the description. Having created the folders, we head back to Jenkins, and we see in the node we created a command line script that we need to run in the remote automation desktop. By running this script, the automation desktop will be represented as this node in Jenkins. Okay, before we run the script, let's set up the version control server. This is where the project being worked on by the programmers are stored. Recall the principle of operation. When we have a new revision in the version control server, then Jenkins triggers this node, which is the remote desktop, to start TIA portal and run the test cases to test the project. So now we have set up the Jenkins server and created a node that represents the remote automation desktop. Now we want to set up the multi-user project server. For more details about the multi-user server and how to set it up, you can find it in this documentation. I will be showing how to do so in a moment. To set up the project server, which I also refer to as the version control server, I must have TIA Portal Project Server installed. Application can be found in Siemens page, as seen here. Let's say this is the server where I want to set up the version control server. Having installed the project server application, I will open the project server configuration application and add the path where I want to store the project server. Then click on Install Service. Got an error, I will click on Install Service again. And here we have the project server installed. I will now start the service. Do take note of the address here. Now I can open TIA Portal and connect to this newly created project server. To connect to a project server in TIA Portal, we open TIA Portal, head to the project menu, select Project Server, select Manage Server Project, and select Manage Server. In TIA version 17, you can add the server by defining an identifier in the server alias. I call it Jenkins_CI. Then you can fill in the address and the port of the server. Now I will proceed to create a new project. You can give it any name you would like. Should you want to integrate the CI process in your process workflow, do kindly reach out to me via the email address in the description. Here I have the CPU added to the project. I can now add this project into the server I just created. Do kindly like and subscribe to get latest updates like this from our channel. To add the project, I click on Manage Server. Here I am connected to the project server earlier created. I will click on the first row. This will bring this window, which selects this project currently opened. By adding, other developers can access this project on the server and work on it at the same time. To proceed, we open the project in its multi-user environment, which is indicated by the green icon. In the Project Server Administrator window, The server can be added to the administrator window by clicking on the Add Server button and defining the details of the server. We can monitor the projects that are connected to the server and see the developers as well as the version history of the project. Now that we have Jenkins set up and the project server set up, we can proceed to prepare the automation desktop, which needs to be connected to the Jenkins server as a node. Please don't forget to click on the subscribe button, like or share, as you may have found any of our videos helpful. By doing so, you encourage us to make more helpful videos. And if you would like us to set up this CI process workflow in your control system, do kindly reach out to us via the email address in the description below. Here is the sequence of flow. So basically, the automation desktop does the testing of the project. The developer would have made an update in the project, so the version control server gets updated with the new revision. Now this automation desktop will know that there is a new version of the project via a Listen console application. Then Jenkins, which is the continuous integration server, starts a process of exporting this new revision from the project server into this remote automation desktop via a project export application. When the export is completed, then a test runner application will be called to open the latest revision of the project being exported and run the test of this new project version. Finally, it transforms the test result to an XML file that will be sent to and can be read by the developer. Not to worry, we will go through this setup as we proceed. Basically, all this tasks executed needs specific scripts and applications, which we can download via the Siemens page here. Here in the Siemens page, we can download the scripts and application which we will use in setting up the automation desktop. In order to establish a connection with Jenkins and perform the test processes, I will walk us through how to set the automation desktop. Do kindly stay with me here. Here are the downloaded files, and I have them unzipped. In this documentation that guides us through how to set up the applications we downloaded, it states the file path where we need to extract the downloaded applications into. We will be extracting the application files into a Tools folder, so we create a Tools folder in the root directory C, and we add the extracted files into this Tools folder. Let's take a look at each downloaded folder one at a time. The export application, which helps to export the project into this automation desktop, and the Listen application, which listens to the version control system for a new project revision, can be found in this Project Server Tools folder. And we need to move them to the Tools folder, so I will just drag and drop the folders there. Here are the folders where the application is stored, and we need to update the name as we have in the documentation. We need the name of the directory this way. So the Listen application is stored in this folder, the application that carries out the exporting of the project is in this folder, and the application that does the testing is in this folder. For this Listen application, Export application, and Test Runner application, we have the corresponding script that calls the application to run, and we can find these bat scripts in this extracted setup_proj folder. Here we have the Listen script, which calls the Listen application to check for new revisions, and then we have the project export script, which calls the project export application to export the project. The same applies to the test script, which will call the test runner application in order to run the test of the project by opening TIA Portal. I will just move them to the Tools folder. And here I have the test runner application that actually opens TIA Portal and runs the test. Here is the transform XML, which transforms the test result into a JUnit file. Also, we need this in the Tools folder, and we need to adjust the folder name as in the documentation. Also, this test runner folder name needs to be updated. As we see in the documentation, the name referenced is just test runner. Here is the bat file of the Listen console, which opens the Listen console application. I will open the script, and here we see the reference call to the Listen console application. We see that the name of the folder needs to correspond in order for this bat file to launch the Listen console application. I will come back to the script soon. Here is also the export bat file referencing the export application. Now we have the applications ready for use in the automation desktop, and we can proceed to test the applications by running the bat files one at a time. Then we use Jenkins to automate the process. Now here's the document that shows how to set the export and listen bat files. As indicated in the document, the listen and the export application interacts with the project server. One checks for new revision, while the other exports the new revision into the automation desktop. We will start by testing the export application. In order to get the export application to export the TIA project from the version control server into this automation desktop, as we see in the documentation, here we need to put in a login credential of the version control project server inside of the automation desktop. This credential enables the remote automation desktop to access the project server using the login account to be configured. Let's proceed to do that. We open Credential Manager, select Windows Credential, and click Add a Windows Credential. Here you add the project server name or its network name. I will then add a user account that can access the project server and the password of that user account. Now that we have the credential of the project server added, let's proceed to test the export application. To do this, we will open the export bat file, which calls the export application, and then we will modify the argument variables of this call command in the bat file to the actual value. These argument variables would take in the actual value from Jenkins, which is the continuous integration server. So I will specify here the version control server I want to access. Here I specify the project name. Here, the revision of the project. And here, where I want the project to be stored. This is the folder we had created when setting up Jenkins, and here is where we want the Jenkins artifacts to be stored. As we see here, we do not have the project exported yet in the folder. Here is where we have the export console application that will be called via the script we will be running in command prompt. So now, we will generate the project export by running this export script in command prompt. We open command prompt and run this export application with these parameters in order to export the file from the server to this automation desktop. Here we see the project exported into this folder path of the automation desktop, which the test runner application can access to carry out the test. Now we have successfully tested the project export application. We will proceed to test the Listen console application, which listens for a new revision in the project server. Before we test the Listen application, we need to create the Jenkins template job. This Jenkins job does the automated execution of this applications, that is the project export, and test runner application will be executed by this Jenkins job. If you would like us to set up this CI process workflow in your control system, do kindly reach out to us via the email address in the description. So here's the Jenkins application. To create a Jenkins job, I will select the new item, enter the name of the Jenkins job, and select Freestyle Project, then click OK. This would take you to this page. You can find the information about creating the Jenkins job in the documentation, which I will be referring here. To start with, we need to create something like a global variable. Here we refer to it as string parameter. What happens is values will be passed using these string parameters. The string parameters to be declared, as we see in the documentation, are the server URL, the project name, and the project revision. Here in the default value, I will be using a placeholder. When we would be running this Jenkins job later in the video, I will be adding the actual server URL and the project name. I have now added the project name parameter as well as the project revision. Next, we will need to add the label of the node representing the automation desktop, which is the remote computer where we have the console applications and where the testing of the project will be done. In this case, we have created the node called Jenkins_CI, and here we can find the label name we assigned to the node. I will copy the name into the field here. And here in the document, we can find more details on what the label represents. Next step will be to add the build step. Here, the goal we want to achieve is to enable the Windows bat script in the Tools folder of the Remote Automation desktop. Recall we have export bat file we tested and also the test runner bat file in the Automation desktop. With this build step, we can call the bat file to execute its application while passing the correct values. Don't forget to like and subscribe. So first we will add the export build step. As we see here, the file path to where we have the export bat command is being referenced, and we have the string parameters being passed to the bat file. The second build step we will add will be the stylecheck_TestSuite bat file, which is the call to the test runner application in order to test the project. Here is the bat file in the Automation desktop computer. I would need to put in the correct name in the build step as it is in this file path. We can proceed to save this current job configuration we have. And here is the Jenkins job we just created. Now that we have this done, we can proceed to configure the Listen Console application. We want to configure the Listen Console so that it knows the Jenkins server to look at, also to know the right version control server to point to, and the right project to point to. The documentation here shows how to configure the Listen Console. As we see here, we have the lists of parameters which can be passed to the Listen Console application in order to get it configured. We will proceed to run the config script in command prompts. So here in command prompt, I will point the directory to where we have the Listen Console application. First, we will add the Jenkins server parameters to the config file. Then we will add the version control server details to the config file. With this script I have here, we can add the Jenkins server details. We need to define the path where the config file will be created. Also, we assign the Jenkins URL, the Jenkins username, the API token we had generated when setting up Jenkins earlier in the video. So I will just copy it from where I had it saved into this password parameter. We will define the name of the Jenkins job we had created and the label of dJenkins node. Now that we have defined the right parameters to configure the Jenkins server to point to, we can run the config script in command prompt. When we do so, we would have a config.xml file created here in the folder. Here, we see the config XML file. Here we see that the correct values are being defined in the XML file. So if the parameters are not correct, we can come here to edit the parameter directly. Next step will be to add the version control server. Back to the documentation, we also have the sample script to add the version control server parameters. I will copy and edit the script to the correct parameter we need to add the version control server. By executing the script in command prompt, the config file will be updated, which will include the project server to the file. We see it successfully added to the config file. I will open the config file, and here we see the version control server info. Next step is to exclude or include projects in the version control server. We do not have projects we want to exclude, so we will look at the include script. What the include script does is to add projects we want to run in Jenkins. This means Jenkins will only run the project added to the include list. I will copy and proceed to edit this parameter before running it in command prompt. So here was the script we modified to add the Jenkins server, and this one added the version control server, and this is to add the project we want to test. Here is the name of the project we want to include in the configuration setup. Here we have successfully included the project in the config file as we see here. We proceed to run the listen config script. In the documentation, this script will check to see if there are new revisions of the project we have included. And if there is a new revision, a Jenkins job will be triggered. The Jenkins job we had created is not tested for error yet. To test for error, I will need to manually build with parameter, but I will do that after testing the listening console. So we will run the listen console on a Jenkins job that has been tested. In order to get the listen console trigger the Jenkins job, we need to ensure that this node, which represents the automation desktop, is connected to the automation desktop itself. As we see here, it shows that it is not connected. We establish the connection between the Jenkins server and the automation desktop by copying the command here into the command line window of the automation desktop. Say this is the automation desktop. I will run the script here. We are getting an error which says, could not locate server. Here it says it appears to be publishing an invalid X instance identity. It happens that there is a missing plugin in Jenkins which has not been downloaded. In case you have similar error message, we can resolve this by installing the SSH Build Agents plugin, as you see here. It's been installed. Another plugin being installed is the instance identity. I will proceed to run the script again. Now we have the connection established. Now I can proceed to test the Listen Console application. The Listen Console application will be triggered by the listener.bat file. The listener.bat file contains the call to the listenconsole.exe application, which passes into itself the config.xml. Basically, the listener.bat file runs every 10 seconds, where the Listen Console checks for new revision of the project in the version control server and then calls the Jenkins job, then a log file and a data.xml, which contains record of the scanned project from the version control server by the listener application will be created. I will copy the command and execute it to call the Listen Console application in command prompts. Here we see the directory is incorrect, so we need to point to the directory where the Listen Console application is. Now that we are pointing to the Listen Console application directory, here I will ensure the command is well edited to run in the command prompt window. We now run the command, and a log file will be created in the directory. From the log file, the execution shows that creating the Jenkins job had failed. Okay, by taking out this part of the script, we can exclude creating the log file, so we can see the execution result directly in command prompt. Before running the script again, I will delete the previously created data.xml so that it can scan the version control server afresh. The execution shows that a Jenkins job could not be started. This is usually due to the config.xml file not having some parameters properly defined. I will proceed to edit and check that the template job name is correct. Here we see the template job name is the same. However, the Jenkins URL looks wrong, so we correct it by taking out the extra texts here and save. Okay. Let's proceed to run the listener command again, and we see the error no Jenkins job. Let's check the username this time. So we open the Manage Jenkins, head to Users, and we see that the username I used is UpC. I do a final check. And now I run the command, and here we go. The listener gets to see that the revision 1 has not been tested before, so it starts a Jenkins job to test the project. And here we see the Jenkins job, which has same name as the project running. We can check the console output of this Jenkins job to see what is going on. Right here we see the parameter values are being set. Then we see the execution of the first build step, which exports the project from the version control server into the automation desktop being called. And then we see the next build step, which is the testing of the application being called. Although the result shows no style guide and no application test in the project, we will proceed to create an application test case in a few minutes. Now that we have checked to see that the listen console works, which gets launched via this listener.bat file, and in the listener.bat file we have a command that runs every 10 seconds to scan the version control server for a new revision, which then launches the Jenkins job if a new revision exists. Note that we had made use of an error-free Jenkins job to test the listening console. Now, I will walk us through how to get Jenkins job we had earlier created to work without error. I will do this by manually building with parameter. Previously, when creating the Jenkins job we had used a placeholder in the string parameter. I will update this placeholders. Here I will be adding the project server URL. Here I will be adding the project name, here the project version, v17 or v19. You can find the project revision from the version control server administration application. An additional parameter is the revision of the project. We would not give any value here, as this will be auto-filled by the listener application. I will proceed to check the Jenkins job by building manually, so I select Build with Parameters and insert the values. We'll manually add the server address, the name of the project we want to run in Jenkins, and then the version of this TIA portal. Note that these values need to be correct, else the job will not be executed successfully. So when we execute this job manually, by clicking on the Build button, we see the job running in the build history. And we can access the console output. As we see in the console output, the values of the parameters are being set. We see the server URL, project name, revision ID, and workspace being set. Then the build steps, that is the export and test build step, configured in the job will be executed. Since the automation desktop is connected to Jenkins job, these steps will access the corresponding BAT files in the automation desktop location C drive, tools folder, and then use the value set to the string parameters to first do an export of the project into the workspace. When that is completed, the style check TestSuite.bat script will be executed as well, which will perform the actual test. As we see here, the next build step, which is to test the application, failed. The issue seemed to be with the file path. As stated, the system cannot find the file specified. Here in the folder, we see the project successfully exported. In order to troubleshoot what the issue is, let's look at the job configuration once again. We head to the build step, which led to a failure, that is the style check TestSuite.bat. Here in the automation desktop, I will open the TestSuite.bat file. Here we have the string variable being passed from the Jenkins job into this BAT file, which has the test runner console application carrying out the execution based on the string parameter provided. Here in this folder is where we have the test runner console application. What I am going to do is to try to execute this command. This will enable us troubleshoot the error closely. First, I will need to point the directory to this folder part. Next, I will need to replace the global variables like the workspace variable we have here, which represents the file path of the workspace. In this command, I will replace this global variable to the actual parameter values to have it executed successfully. As we see in Jenkins, during the execution of the job, the workspace directory is assigned the file path, which is then passed to the stylecheck TestSuite.bat file. So instead of workspace, I will add the actual workspace directory. Having done this, I will execute the command in CMD. Seems the path to project is not valid. Let's head back to the bat file. Here we see the project assignment to the project file path, which should have the actual name of the project, and not project/project.ap17, as we can see in the folder path here. I will add the correct project path name and run the command. As we see here, the application is executing successfully. To recap, we have this batch command in the Jenkins job, where the string parameters are passed into the bat file, and by having a look at the bat file, we have the string parameters defined in the command. However, I observed that this should be global variables, that is, they should be having percentages. By assigning the global variable, which holds the project name, we should be able to resolve that problem. In addition, we open the project export.bat file to see if there are any issues as well. I see here that there is an added command which I think is not relevant. Following the update we did in the style check.bat file, we just stick to the exporting command and not rename the variable. So we proceed to Jenkins job and let's try to run the manual build again. Now we see compared to the previous run, we have the style check.back running, and we are able to start the application test. But while trying to open the project, we get another error. Here we see that the logged in user is not a member of the TIA openness group, which throws a security error in this case. To resolve this, we need to head to the local group policy and add this logged in user into the TIA openness group. So if you have this kind of error message, you would need to ensure the account signed in to the remote automation desktop has been added to the Siemens TIA openness. Now that this is completed, I would need to restart the automation desktop and then run the job once again. I have restarted the PC. We are able to see Jenkins execute the job successfully. So we see Jenkins do an export of the project version from the version control server and open the project. However, since we do not have any test cases defined to check the functions in the project, we get the result, no application test selected. And here in the Jenkins dashboard, we see the job with a green icon checkmark showing the last execution was a success. Now that we have seen the Jenkins job executed successfully using the build parameter in the Jenkins server, where the Jenkins job was able to export the project and then run TIA portal to do the test, which shows that the Jenkins server is communicating properly with the automation desktop. I will proceed to the next steps where we want to see how a new revision in the project server, which is the version control system, can trigger the Jenkins job to do an application test for us. To proceed, I will check the listenconsole.bat file, which scans to see that there is a new revision in the project server. Next, I will create a simple function in the TIA portal project Jenkins CI, which is connected to the version control project server. After creating the function, then we will write a simple test case to check that the function does as it should. Now let's proceed. Now that the project is opened, I will proceed to write a simple add function. I will give it the name simple add. The function has two input variables A and B and an output variable C. Now I will call the function into the main OB. Now that the function is ready, I will write a simple test case to check that the add function works well. To use the TestSuite, the package TIA Portal TestSuite Advanced needs to be downloaded and installed. Link can be found in the description below. By doing so, you would have the TestSuite application added in TIA Portal as seen here. The TestSuite application allows you to check the project for consistency in styles by defining certain rules, for example, how you name your variables. Also, the TestSuite checks if your application or functions written runs correctly by using written test cases. In our case, we are concerned about writing test cases to check the functionality of the software. Here in this document, TIA Portal TestSuite Functional Manual shows how to write the test cases in TIA Portal. It contains information on how you can check for style guide in the project. For example, using correct naming for your variables in the programmed function. And it contains the application test, that is test cases, to check your functions. We are concerned with the application test, so I will go to the page. As we see here, the support simulation needs to be activated in the software, else the test case would not run. I will run the job without activating the simulation support, so we see the result, and then I will proceed to activate it. In the document, you would see how to prepare the test case, which I will show now, and the test case would look like this. First, I will create a new test case. Note that TIA version 17 requires you to prepare the test case while in Server Project View, which we will see soon, so if we prepare the test cases here and check into the server, it would not be uploaded as we do not see any blue marking here. However, TIA 19 allows you to prepare the test case in Multi-User View. I will write the test case here and copy it, and then paste it in the Server Project View. First, we will need to define the scope, that is the PLC, where you have the function we want the test case to check. As we see here, the PLC is named PLC1. Having defined the scope, then we declare the variables we want to use in the test case, and map the variable to the variable used in the program logic. Next step is to define the steps. Note that the steps of a test case would follow this pattern, which is known as the AAA, that is, arrange, act, and assert. First, we define the input variables in this step, which is the arrange. Then we act. This involves defining the cycle time you want the PLC to run in order to generate your result. Then we assert. This involves checking to see if the result is what we had expected. Now we proceed. I define the input to this step, and then the number of cycle taken to expect the result, and then the result I expect to have. Recall that I am in the multi-user project view, so if I check into the control server, then this information would be lost, so I would copy the test case, open the server project view, and paste it in there. Now I will proceed to check in, and we will see that the test cases are not uploaded. Here, we get the message that the change made was checked in successfully. As we see, the test case was not transferred into the server. So we proceed to open the server view and insert the test cases. However, note that version 19 will permit you to write the test cases in the multi-user project view. Now I am in the server project view and I can insert the test case in here. I will carry out the same action as I did before. Here, instead of checking in, I will click on Save. Please don't forget to click on the subscribe button, like, or share as you may have found any of our videos helpful. By doing so, you encourage us to make more helpful videos. Should you want to integrate the CI process in your process workflow, do kindly reach out to me via the email address in the description. Here in the project administration, I can see the revisions. By running the listener, we will have the Jenkins job executed, because the listener will scan to see the new project revisions. And we have 2 revisions already prior to the previous scan, so we would expect 2 jobs to run. As we see here, we have the 2 jobs launched corresponding to the last revision history. I will check the console output to monitor the execution of the commands. As we see here, we have an application test case detected, which means we can run the test case to check the concern function, which is a simple add logic. However, we have a message generated saying the simulation support has not been activated. Here, I will cancel the first job. Recall I had mentioned the simulation support needs to be activated, but we had not done that. And that is the error message we received here. To proceed, we need to enable support simulation. Another message we see is that the PLC has to have safety disabled in it. This is because the style check application downloaded from the Siemens page while creating this video does not have the functionality to check a project that has the safety feature enabled. However, in the second part of this video series where we look at running the automated unit testing on a V19 project, I will be using a custom-made TestSuite application check on safety projects. If you would like to have this integration done on your control system, do kindly reach out to me via the mail in the description below. To make changes to the hardware configuration when working on the multi-user version control server, you would need to head to the server mode to make the modification. In this case, we need to enable simulation and also disable the safety feature of this PLC. However, as earlier mentioned, in TIA Portal V19 we will use a custom test application which I have developed to test a safety-enabled PLC with Jenkins. Back to TIA, now I will first disable the safety feature and save. Then we will see that the Listen console will detect a new revision in the project server. As we see here, the Listen console is still running, and a new job will be called in the Jenkins server to carry out the test of the project. Here we see the 4th job is being executed. I will abort it in order to proceed to enable the simulation in TIA Portal. I will open the project in TIA, head to Server Project View to enable the simulation. Since it's a modification to be done in the hardware configuration, this means I will proceed to the server view and make this update there. And upon saving this modification, we have the Listen console, detecting a new change and triggering a Jenkins job as we see here. The 5th Jenkins job of the project. We proceed to check the console output of this job. Here the project has been exported from the version control server and is being opened. The console output also shows that the conditions are fulfilled, that is, we have simulation support enabled and safety features disabled. Here, we see that the result shows the execution was successful, and the test case result will be published in the Jenkins workspace folder path of the remote automation desktop. Please don't forget to like and subscribe. This will help this video also reach more audience should someone out there also need it. Here is the folder path where the test result is stored, which is Jenkins, workspace, Jenkins_CI, which is the project name, and the folder, logs. And here we see the test result. In addition, this test result can be shared to the developers via email or other means of processing the test case result, such as with the use of an application called Qtest, where Jenkins publishes the result to the Qtest application, and you can log failed test case results as bugs in Jira. Should you be interested in more info on how to process the test result, with Qtest using Jenkins and Jira, you can drop a comment, and I will create an additional video about this. This brings us to the end of this first part of the video series on continuous integration, where we have looked at how to set up the automated unit testing or an agile process on V17 TIA Portal project. In the next video part, we will look at how to set this process on V19, which is more flexible to work with compared to TIA V17. On V19, we will as well be able to run test cases on safety integrated PLCs and also view the content of the JUnit test case results being published after the execution. Also, in another video, I will show how to make use of GitHub as the continuous integration orchestrating software in order to carry out the automated unit testing process on TIA Portal rather than Jenkins, as used in this video. I do hope you have been able to learn something interesting, and do kindly like, subscribe to our channel, or drop a comment. See you in the next video. Thank you.